Today we're going to create this really cool jungle bridge completely with simulation nodes, and it will be concluded with the physics, as you can see over here. By the way, this Blender file will be available on my website mtranimation.com, and with that being said, let's get started. Before this tutorial, the first thing that we're going to do is removing the camera and the light. Press X to delete them. Now I want to import two empties, so let's press numpad 1 to go into side view first, and now let's press Shift A and let's do an empty plane axis. Move this one to the other side over here, and then when you press Shift D you can duplicate a new one to over there. These two empties, I'm going to rename them in the collection over here. I'm going to name this one the left empty, and I'm going to name this one the right empty. And with this setup, we can start doing the geometry nodes. So let's go into geometry nodes over here. Let's click on the cube, and that's what we're going to do the geometry nodes on. So let's click on new over here to create a new geometry nodes. We don't need the group input because we don't need the cube. So we're going to press X to delete that. What I want to start with instead is Shift A curve line. For this curved line, what I want is that the end connects with this empty and the beginning connects with this empty, or reversed, doesn't really matter that much. To do this, let's add in two set position nodes, like this. And the positions in the two set positions should be the positions of the left and the right empties. Let's drag in the left empty into our geometry nodes, and let's also drag in the right empty into our geometry nodes. Let's connect the location of the left empty to the position of the first set position. Then you will see our curve is gone. That's because the whole curve is now going to this empty, which we don't want. We only want that the end part goes to there. So we're going to import an endpoint selection so that we can say only the start or the end should go to that empty. So let's connect that with the selection of the set position. And now if you turn off start size, then you will see it's only the end that goes to that empty. Same thing that you want to do in the next set position. So we connect location again with the position. We can press Shift D on this endpoint selection and put that over here. And then we can connect this endpoint selection with the selection again. The only thing we have to do is switch the start size and the end size like this. And now we have a connection between the two empties. Later in this tutorial, we're going to make a simulation that will make it that the curve will go hanging like this. However, right now, our curve only consists of 2 points, like this point and this point. So it's going to be impossible at the moment to make this curvature. For that, we need to make more points along the curve. So let's do that by adding in a resample curve node and place that at the end. And we can keep the count on 10. That's completely fine. From here, let's start doing the simulation. So let's move our group input over here and let's add in a simulation zone. And let's connect the resample curve to that and the simulation output to the group output. We want to simulate a lot of points, like the movement of some points. So we will have to add in a set position node right over here. And I also want to set an initial velocity. So if you click on the simulation input, you can click on N to make this sidebar open up. And then if you click on plus, we can add in a new attribute. This attribute is going to be the velocity attribute. And this velocity attribute, we're going to make it from geometry to a vector. Let's connect the beginning velocity with the end velocity, and then we get started. First thing that we're going to do is adding in some gravity so that this whole curve falls down. So let's do that by adding in a very simple vector math node. And let's add that in over here. Connect this also with the offset of the set position. And since we want to have gravity, let's make the z-axis like minus 0.04 or something like that. And now you will see if you press play, it will start falling down. Yeah, it starts falling down. However, what I want is that the endpoints of the curve are not falling down. Those should like stick to the empty. So what we can do is pressing Shift A and insert a switch node. And this switch node is now on geometry, but I want this to be on a vector. And with this switch node, what we can do is like you have this switch over here, you can turn it on and off. If it's off, it will be false, it will be this vector. If it's on, then it will be true, then it will be this vector. So basically what I want with this switch is to add in an endpoint selection. And then we can say, okay, if the point is one of the endpoints, it should not be affected by the gravity. So basically, if this switch is false, it should be the gravity. And if not, it should just do nothing. So let's connect it like this, also with the offset. And let's make some space. Let's organize our stuff. And then if we press play, you will see the endpoints are not reacting to the gravity. One problem that we're having now is that when I press play and I move the empties, the endpoints are not reacting to the position of the empties anymore. They are not following it. And I still want that. So let's simulate that they will follow the empties. So in other words, we want to change the vector of the true value over here. To do this, let's take the two object info nodes that we have over here and press Shift D to duplicate them. Place them kind of like over here. And I want from each endpoint to have the live direction to each empty. And we can get this by adding in a position node. And to get the direction to each empty, we can add in two vector mask nodes, which we both set to subtract. And then if you subtract on both things the position of each thing, so like this, and then for this one, like that. Now we're having for each endpoint the direction towards the closest empty. And now to say that this point should go to the left one and this point should go to the right one, we can import another switch node, which we also set on vector. And if we connect this one like this and this one like that, we want to say with another endpoint selection, if the endpoint is the end size, then it should go to the right one. And then let's also connect this new switch node to the old true value. And you will see it goes a little bit wrong. It goes like reversed, right? That's because I was a little bit confused. We have to set the start size on 1 over here and the end size on 0, and then it will work. And you will see they will keep following it. Let's create a little bit more space over here so that we have more overview. Yeah, like this. But now we still don't have like the physics of a rope that is hanging. It still falls into oblivion. To get that physics, it's actually quite easy. It doesn't require that many nodes. So what we want to do is we want to add in a position node. We want to get the position of each point on the curve, and we want to blur that position out with a blur attribute node. If we set this from float to vector, we can connect the position over here. Let me make a little bit more space. And now we want to subtract the original position of each point from the blurred position of each point with a vector math node. We set this from add to subtract. You can subtract from the blur the original position. Now this difference in blur and original, if you add that to our original velocity with another add node, we can connect that like this, then you're getting rope physics. Just like that, and that's really cool. The cool part is you can take like one of the empties and it will automatically react like this, like a real rope, or like a bridge, of course. This is quite it for the physics part. From here, we're going to procedurally create the jungle bridge along this curve. This is the end result that we're going to have, and what I want to do first is to create one side of the ropes like this. Just one side, and then we can duplicate that to both sides. So let's create one side of this. So basically what I mean is now we're first going to create like a rope that goes like this and a rope that goes like that, and we're going to create the connection points between that. Let's first create the lower rope, and the lower rope is going to be quite easy. We're going to move the group output to here, and basically what I want to do is I want to give thickness to this curve. So let's press Shift A and do a curve to mesh node, and as the profile curve we want to do a curve circle, and let's connect that with the profile curve, and then we're getting thickness. Let's set the radius of the profile curve. Let's set that on 0.04. And then we're having our first rope. To organize our geometry nodes a little bit better, what I like to do is take these and let's press Ctrl J to create like a frame around it. And this frame, let's press N to make this pop-up open. You can give it a label. Let's name it like lower rope. For the upper rope, let's literally take this whole thing and press Shift D to duplicate it. Let's connect the simulation output to the curve to mesh again. And the only thing that I want to do is move this curve a little bit up. So let's press Shift A and add in a transform geometry nodes right over there. Put that in our frame. And let's add in a join geometry node so that we can join the upper one and the lower one together like this. And now if you set this higher, you can see we have a second rope. Let's set this on 0.94. I do think it will look better if the upper rope is a little bit thinner than the lower rope. So let's set the radius of the curve circle of the upper rope to 0.02. Now for those vertical parts, I want to instance a lot of curve lines along the lower curve. So let's do a curve line node. And to instance it on the original curve, let's do an instance on points node. And actually, let's take the lower rope and the upper rope and let's move it over here. I also forgot to rename this frame over here to upper rope. Let's do that. And then we have a little bit more space to create our vertical parts. The points are going to be the original curve. And the instance is going to be the curve line. And let's connect this with the join geometry that we added in earlier. So that we have it like this. Now you see these lines are all going vertically. I don't really like that. I want them to go with the flow of our curve. So basically this one should go like this and this one should go like that, for example. So basically I want them to follow the tangent of each curve. And to make the rotation of the curve lines be affected by the curve tangent, we can import a curve tangent node. And if we connect this with the rotation, then you see, yeah, that doesn't really work. That's because we also have to do an align Euler to vector node and connect the curve tangent to the vector. Then you see this will happen. Then you see they are all going down. Well, I don't want this. I want to flip them so that they are going up. Easiest way to do this, in the curve line, let's set the Z value on -1 meter, like this. Then they are going up. You also see that some of them are like over here are like going further than the upper rope. I don't want this, so I want to always that the end parts are always snapping to the closest edge of that upper rope. And to do this, let's realize these instances with a realize instances node so that we can actually do something with the individual points. And we want to move points, so let's do a set position node. And we want to move them to the closest edge of this curve. And to get the closest edge, we can do a geometry proximity node. And we set this from faces to edges. And the target is going to be the curve of the upper rope. So this one. And then if we connect the position with the position of the set position, then you see that doesn't really work. That's because the geometry proximity node only allows to get the closest edges of meshes and not from curves. So we have to convert this curve into a mesh before we do the geometry proximity. So let's do a curve to mesh node. Set that over there. Then you see that still doesn't work because I forgot that we have to say that only the end part of the curve goes to there and not the whole curve. So let's do again an endpoint selection node, set that over there, put the selection into the selection over here and disable the start size. And then you will see they will always go like this. Let's give this curve some thickness by adding in a curve to mesh node and also a curve circle node. And let's connect that over there. And as the thickness, let's set that on 0.015. A little bit smaller than the upper rope. Because these parts are ropes, I think it would be cool to create like a connection point between the upper rope and the vertical parts. That connection point is very easily just going to be like a torus object. So let's create a torus object by pressing Shift A and let's search for a curve circle. And then let's duplicate this curve circle right over there. And let's also add in a curve to a mesh. With the Node Wrangler add-on, if we preview this, Alt Shift click on the curve to mesh, then we can preview it over here. If we put a curve circle on this, then you will see we will be able to create like a torus object. For the connection parts, I want to have the radius of the first curve circle to be 0.03. And the radius of the second curve circle, I want that to be 0.015 again. And we're having a small torus. This small torus, I want to instance that on our vertical parts. So let's connect the join geometry again so that we have the bridge back. And to instance them on top of this, let's do an instance on points node. And the points are going to be the curve after the set position. And the instance is going to be the curve to mesh node. And then we want to join this together with everything. So like this. And then we're having the toruses over there. However, the toruses are also happening right over there, like on the bottom. I only want them to happen on the top of each curve. So with an endpoint selection node, put that over there, we can say, okay, we put this into the selection, and then we can say only the end size should have these toruses. These torus objects, I also want those to be affected by the curve tangent so that they follow that. So also over here in this rotation, let's take the previous curve tangent and the align Euler to vector, and let's press Shift D to duplicate that. Go over there and let's connect this with the rotation. Let's make it that the vertical parts are going to be excluded from the endpoints of the curve. And we can do this by adding in an endpoint selection node. And if you connect this with the selection of the first instance of points over here, then you see they are only on the endpoints. But to reverse this, we can add in a map range node, connect that over there. It's now going from 0 to 1, but let's switch this, that it goes from 1 to 0. And then we only have it in the middle parts and not on the outer edges. If you want to have control over the amount of vertical parts along your bridge, you can add in a resample curve node and add that in right over there. And with this you can have control over like how many you have. I will select all the nodes that create the vertical parts, press Ctrl J, and I will name this vertical parts. So now we have our side parts. The only thing is we only have one of them. I want to have two of them. I want to have one over there and one over there. Basically, I want to create a mirror. So let's do this. After the join geometry that we have over here, I want to insert two transform geometry nodes. So one over there, Shift D, and one over there. Connect this one over there. And then I also want to join these together. So join them together like this. I want that in the first transform geometry, the y-axis is on a 1. And in the second one, the y-axis is on -1. So that we have it mirrored. If you want this to be automated, so that this one is always the positive version of this one, you can import a value node. And let's set this value on 1 for now. And let's also add in a combine XYZ node. Actually, let's add in two combine XYZ nodes, like this. Connect this one over there, connect this one over there. And the y-axis, I want that to be controlled by this value node. However, this y-axis should always be, with a math node, should always be multiplied by -1. And now you will see you have control over like the width of your bridge. Let's now create the 4 poles that we had over here in the end result. And we're going to do this as followed. We're going to start off with a curve line. And I will do Alt-Shift-Click on this curve line so that we can create one pole over here and then create 4 poles around the bridge. So let's first create one over there. This curve line, I want to give it thickness with a curve to mesh node. And then the profile curve is going to be a curve circle again. The thickness of the poles, let's set that on 0.13, like this. And let's make it that they are actually closed. So in the curve to mesh, let's click on fill caps. Now in the final version, you see that the poles have like the ropes like going around it, like 3 layers of ropes around it. Let's create that in our version as well. Before we can do that by adding in 2 curve circles and also a curve to mesh node and connect that like this. Alt-Shift-Click on the curve to mesh to preview this. Let's make the radius of the first curve circle 0.13 and let's make the radius of the second curve circle 0.02. And then we have 1 rope. I want to have 3 of them. And a cool thing that I want to do with this is to add in another curve line node. And I want to instance those ropes on that curve line. So let's add in an instance on points node again. And as the points, we do the curve line. And as the curve to mesh, we do the instance. Let's do Alt-Shift-Click on the instance on points nodes. And we see we have 2 ropes. I want to have more ropes. So let's resample this curve line with a resample curve node. And now you could set this count on 3, but what I actually like to do is set the count on length. And then make the length so that the toruses are barely touching each other like this. And then you can just, with the length of the curve line, you can decide how big your stack is. So like this, I like to set it on 3. Now to combine this whole thing with our pole, let's add in a join geometry node and connect both this curve to mesh and the instance on points with that. And now let's do Alt-Shift-Click on the join geometry and then we're having this. To move this thing up a little bit, let's do a transform geometry and let's move it up like this. Let's connect our last join geometry again so that we can see the bridge. And now I want to instance those poles that we created over here, over here, over there, and over there. And we're going to do this by going back to our nodes for the poles. Let's do an instance on points node. And let's connect as the instance this join geometry. And as the points, it's going to be our original curve that comes out of the simulation output. And now if you connect this with our last join geometry like that, then you see we're getting the poles like this. Okay, two things that we want to do. We only want to have the poles at the ends of the curves, plus we want to mirror them so that we have 4 of them. Let's first make it that they only appear on like the outer ends. We can do this very easily by pressing Shift A, do an endpoint selection, and connect the endpoint selection with the selection of the instance on points. And then it's like this. Now for the mirroring part of these poles, what I actually want to do is I want to reuse our system that we created over here. Because over here we literally created like a mirror system that we can use more often. So I want to convert these nodes into like a group of nodes that we can use on multiple parts in our geometry nodes. So let's select all the nodes that create the joint geometry. So let's disconnect the poles for now from the whole thing. And let's select all of the nodes that create the mirroring part. And if you then do Ctrl G, then it will create a group for it. And this group, I don't need the value over here anymore. I can delete that. I want to have control over here with the value of the y-axis. So I connect that like this. Now, if you press tab, you can go out of this and then you have this node group. Press tab to go into that node group, press tab to go out of that node group. This node group, we can name this like mirror, like this. And then you see if you change the y-axis over here, you still have control over the width of your bridge. I will set this back on 1. But the good thing now is we can take this mirror node and we can Shift D it to here, to before the instance on points of the poles, to here. And now if we add in another join geometry node after the mirror group and we join our poles with that, then you will see we have mirrored poles. And still the gravity of the bridge works perfectly fine. I see that these poles, yeah, we can make them a little bit lower. So maybe in the curved line that creates the poles, I mean this one, set the Z location a bit lower, like this, for example. Let's select all those nodes and let's press Ctrl J, make a frame, and let's name this poles. Now the last thing that we have to do is to create those planks that we have to step on, of course. Pretty important. So let's do this by adding in first a grid, and let's create one step first. So let's do Alt Shift click on this grid so that we can preview it over here. And for the X and Y dimension of this step, I'm going to set the size of the X axis to 0.35. I'm going to set the size of the Y axis to 2.25, like this. Let's give it some thickness, and let's give it some thickness by pressing Shift A, and let's do an extrude mesh node. Let's turn off individual and let's set the offset a little bit lower, like this, for example. However, the problem with the extrude mesh is that we now have a hollow object over here. The bottom part got removed. I want to join this grid with the extrude mesh with another join geometry. Let's put that like this, and let's join this grid to here. Let's instance this plank along our bridge with the group output again so that we can see the bridge. And I'm going to instance these parts on the same curve as the vertical parts so that we have as many vertical parts as there are steps. So let's do this with an instance on points nodes. Set that over there. The points are going to be this resample curve. So I'm going to connect this resample curve with the points over here. And then as the instance, I set the planks. So like this. Let's join this instance on points. Let's join that with the last join geometry like that. And then you see we're getting steps. Now you see these steps are always staying horizontal. I don't want this. I again want to make it that they are following this curve just like the vertical parts are doing. So I'm going to make them affected by the curve tangent again. So let's go back to our instance on points over here and let's do a curve tangent node. Put that over there. And let's do also another align Euler to vector node. Put that over there. Connect the curve tangent with the vector and then connect the rotation with the rotation. And then you see that is like this. You see the planks are acting a little bit weird. And that's because there's something going on with the tangent of this thing. I've been figuring out like why is this happening and how can we fix it. And I figured out that we did something wrong all the way in the beginning of this tutorial. So we have to do something different. It's not so hard of a fix. So let's go back all the way to our beginning. And what we have to do over here is we have to switch the endpoint selection. So this one we set on 1 and this one on 0. This one we set on 0, this one on 1. And then also over here in the switch node over there, we set the start size on 0 and the end size on 1. And then you will see it does work perfectly fine. You see now that the planks are also happening in the beginning and on the end. I don't want this. I want to remove them over there. So let's do just like we did before, a endpoint selection node and also a map range node so that we can invert this selection, make this from 1 to 0, and let's connect it to the selection. If you see some clipping going on with the planks and the lower rope, just add in a transform geometry node right over there and move them up a little bit. If you want to be able to rotate your bridge 90 degrees like this, then you see the results are not so good. If you want to rotate it, you have to change your mirror group. So if you click over here, let's go back. We want to change this mirror part over here. So let's go press tab to go into that. If you rotate your bridge 90 degrees, I want to not do the mirroring over the y-axis, but over the x-axis. So I create a new socket for the x-axis. I also create a new multiply node for that. I connect that like this, and then I connect it to the x. And now you see we also have an x value over here. If you set this on 1 and then the y on 0, then we'll see the bridge is good. However, the poles are still like that. No worries. In the poles, you just do the same thing. So you make the x1 and the y0. You also see that the planks are doing something weird when you rotate it 90 degrees. We can fix this by going over here and adding in a vector math node. Set this from add to multiply, and let's set all the values on 1 for now. And the only thing that you have to do is set the x-axis over here on 0. Then the planks will always be horizontal. I will set my bridge back to its original angle. If you're creating a very old jungle bridge, then it's most likely going to be that some of the planks are going to be missing. So let's make it that we randomly delete some planks. Do this by adding in a random value node. Set this from float to boolean. Then you will see if you connect this with the selection, the higher you set this probability, the more planks there will be. The lower you set it, the less planks. Let's combine this random value with this map range node by adding in a math node. Set this from add to multiply, and let's multiply these two together so that this is always the case and we have random deleted planks. Now we're done with the 3D modeling part of our bridge. Next step is going to be the texturing. And before we do really like the real texturing of it, I want to take a look at what does a texture actually looks like on any of these objects, right? Because does this thing has UV maps? For that, let's create a new material by going into the shader editor. Let's split our screen in half, go into the shader editor, and this material, let's name that the checker material. To check how a texture or a UV map looks like, we can do a checker texture. If you combine this with the principal BSDF, and let's go into the material preview actually, then you see there's nothing really happening. That's because if you're working with geometry nodes, you have to do a set material over here and set this on checker. Then you'll see that looks like this. You might think that it looks good already. However, it's not using the UV map of this object. I want to do that. I want to create a new UV map for these things. So with the Node Wrangler add-on enabled, I click on the checker texture and I do Ctrl T to add in a texture coordinate and a mapping node. If you set it from generated to UV, we can use the UV map. But you see, yeah, the UV map is nothing. It's nothing. We have to create a new UV map inside of geometry nodes. So let's do that first with the easiest example, and I think the easy example is going to be the pole. To create a UV map for curve objects that have like thickness, what we do in geometry nodes is we create a gradient that goes from 0 to 1 over there, and we also create a gradient that goes like from here around the object, like from 0 to here to 1 over there. That way we can kind of create seams to fold this thing out. And to get that gradient information, we can do a spline parameter node. And you see the spline parameter. If we do Ctrl Shift click on it, we can preview it and also do Ctrl Shift click on the curve line node. Then you see we have a gradient over here that goes from 0 to 1. Now I want to transfer this gradient information to this thicker mesh. And you can do this by doing a capture attribute node. Set that over there. And the attribute that we want to capture is the spline parameter vector over here. And now if you connect this with the viewer, then you will see we're getting a gradient that goes from 0 to 1. Now to get the gradient that goes like from here around it, we can get the spline parameter of this curved circle. So let's take this capture attribute and press Shift D to duplicate it over there. And let's put the same spline parameter over there. And then you will see if you preview this, you're getting a gradient that goes like this. To combine the vertical gradient with the horizontal gradient, we can do a combine XYZ node. And let's do as the X, let's do this capture attribute. And as the Y, let's do the other capture attribute. Let's preview this like this. And this looks like a good UV map. To use this vector data, this UV map inside of the checker texture, we have to store it in Blender. And to store it, we can add in a store named attribute node. Add that in over here. We want to set this from float to vector. And the name is going to be bridge UV, for example. And then connect this over there. Now from here, let's connect the set material again with the original one. And then you will see, oh, although we have created a good UV map, it still is not looking good. That's because if you're creating a new UV map in the geometry nodes, you should not use the texture coordinate node in the shader editor. No, let's delete this. We want to do a attribute node. And the attribute is going to be the bridge UV. Connect this with the vector. And then you will see the checker texture will start to look good. You see all around this whole thing, the checker texture looks good. Only over here it looks a little bit weird. If you don't want this thing, you should have more resolution on this curved circle. So if you set the resolution on 100, for example, then you see that effect is already a lot less. But to be honest, later with the wood texture, you're not really going to see that. This is the exact way that we're going to UV unwrap every curve object that we have over here. So let's UV unwrap these toruses, the same way as we did for the pole over here. So let's go to the two curved circles that create this. Let's add in a capture attribute on both of them. And let's also add in a spline parameter. Put the vector both in the capture attribute. Add in a combine XYZ node. Put this one into the X, this one into the Y. And we want to store this data. So with a store named attribute, we can put that over here. Name this the bridge UV again. Set this from float to vector and put the combine XYZ in there. Then you see that looks good. It looks good. It looks fine, I guess. But I think with the checker texture, you want to have it that the fields over here are mostly just squares and not really stretched out. So to manipulate this UV map, you can add in a vector math node. Set that after the combine XYZ. If you set this from add to multiply, set everything on 1. That we have the original one. If you change the Y, then you'll see you make it thinner. If you change the X, then you see you can make it more like this. Make it so that you have mostly squares. Now let's do the lower rope and the upper rope. So for the lower rope, it's actually quite easy. We can just do another capture attribute right over there. And let's Shift D this to put them over here. If you see that your nodes start to be glitching when you place them, you can turn off auto offset over here so that they won't be offsetted when you place them. Let's do another spline parameter and let's connect vector. Vector over there, combine XYZ, put this one over there, this one over there. It's the same story as always. So we can just do a store named attribute node over here, name this like bridge UV and put this on float to vector, connect it like this. And now if we want to make this more like squares, we can do a vector math node, set this from add to multiply, multiply everything by 1 first. Let's see, we want to do it over the y-axis so that we have it like this. Same story for the upper row. So for the upper row, do another capture attribute node and another one, so Shift D to put it over there. Let's make a little bit more space. Let's do a spline parameter node and let's set the vector both over there. Another combine XYZ like this and like that. Store named attribute. Set this from float to vector. Put it like this. Bridge UV. And then we have this. Let's manipulate it again with a vector math node. Set this from multiply. Set everything on 1. And let's do the x-axis this time. Yeah, like this. You see a weird thing happening over here. As you remember, we can just set the resolution of this curved circle to a higher value, and then that is less. Now for the vertical parts, let's see, I want to capture the spline parameter of this curve line node over here. So let's do a spline parameter and a capture attribute right over there. Connect this with the vector. Yeah. Then I also want to have the capture attribute on the curve circle over here on the end. So like this. And let's also copy the spline parameter to that, so that we can connect the vector with the capture attribute. Now if we again do a combine XYZ node, we can connect this attribute to here and the other attribute to the Y-axis. And with a store named attribute, we can connect that on this one. Float to vector, connect it like this, name this the bridge UV. And then that looks like this. Let's manipulate this with a vector math node. And let's set this from add to multiply, set this on 1. And let's make the y-axis higher so that we have nice squares over here. Now the last thing that I want to UV unwrap is the torus object that we have over here. So we have to do that inside of this. Same as before, capture attribute both over there and over there. And then with a spline parameter node, connect the vector again. I know I'm telling the same story over and over, but I want this to be very clear, because if you don't do it right, then you're getting weird results. Now let's do a combine XYZ node, place that over there, put it like this, put it like that, store named attribute, float to vector, vector to value, name this bridge UV, then that looks quite good. I want to manipulate it a little bit with a multiply node, just like that, set it all on 1, and then make it like this. Now we have UV unwrapped everything that I want to UV unwrap. Don't you worry about the planks, we'll use a different technique for that, for the texturing. But let's now texture everything. Let's first texture the ropes. Those are all going to have the same texture. That's going to be this texture. I got all the textures that I'm using in this tutorial from textures.com, link in the description so that you can also download those and use those. And with that being said, let's create the textures. By the way, I'm not going into too much detail for how to create the textures. I'm just simply going to use the Node Wrangler add-on to automatically do the principal texture setup. Let's change this checker texture into the rope texture. And then let's delete everything that we have over there. So now let's click on the principal BSDF. Let's press Ctrl-Shift-T and let's open up our rope texture. Just like this, principal texture setup. And then you see it doesn't really look good. That's because the Node Wrangler add-on by default uses the texture coordinate node, and we don't want that. So we do X to delete this, and let's do an attribute node, and we want to do bridge UV, and let's connect the vector with the vector. And then you see we have a very nice rope texture going over our objects. However, the poles should not have this rope texture. So what I'm going to do is I'm going over here and I'm going from this join geometry, disconnect the rope, and I'm going to do another join geometry after the set material. And on this join geometry, I'm going to join the ropes again. And this way I can duplicate the set material to this one. And I'm going to create a new texture for the poles. So let's go over here into the material properties. Let's click on this plus icon and let's click on new and let's name this poles. For the poles, I'm going to use this texture. So let's go into the principal BSDF and let's do Ctrl-Shift-T again. Let's search for our textures. It's going to be this, this, and this. Let's add it in. And of course, it's still the rope texture because I haven't changed it over here. Let's change this to poles. And again, let's do the attribute node over there with bridge UV. And let's connect that like this. Now we could scale this texture like this, for example. And then I think that looks pretty good. Oh no, I see I'm making a mistake over here. The ropes that are going around the pole are also having like the wood texture. I forgot about that. So let's disconnect this one over here and connect it with the join geometry and disconnect the set material. We want to put this set material somewhere else. So let's go back to the nodes that create the poles. The set material, I'm going to put it before this join geometry over there, so that only the poles get the wood part. Then I'm going to Shift D this set material over here, and I'm going to change this to the rope so that we still have the rope over there. Now let's create a new material for the planks. So let's click on the plus icon over here, click on new, and let's name this planks. And let's also go to the planks nodes that we have created right over here. And let's do a set material over there. And let's name this planks. And also we want to do the same thing. We want to disconnect this one from this joint geometry to this one. And now that I'm seeing is we can delete this joint geometry by pressing Ctrl X. We don't need it anymore. For the planks, I'm going to use this material. So let's click on the Principal BSDF again, Ctrl Shift T. And let's search for the plank material. It's going to be this one, this one. Then you see that doesn't look good. That's because we didn't really create like a UV map for this thing. Well, to make this texture look good on the planks, we don't need to have a UV map. We can just in the texture coordinate node, we can set this from UV to object. Then it will already look better from the top, right? From the top it looks good, but from the sides it does not look good. It's very much stretched. That's because it's now only mapping these textures from above, like it's projecting it from above, and then the sides are like very stretched. I want it to be projected from the top, the side, below, and another side. So like around it. To do this, select your 3 textures. And in one of the textures, hold down Alt and set this from flat to box. And then you will see it looks good. Another thing that I want to change is that, yeah, it doesn't really look good if the planks are like perfectly the same thing, right? I want to randomize that a little bit. So the location in the mapping node, I want to randomize that with an object info node. If you put the random socket into the location, then we're getting random variations of the location of the texture. So that's how you create a jungle bridge in Blender completely with the physics. If you like this video, please give it a thumbs up. Comment down below if you have any questions. And if you want to help out the channel and you don't want to miss out on any future videos, please subscribe to the channel. And by the way, if you ever have a problem in Blender that you just cannot solve and you want me to take a look at it with you, go to my Fiverr page and we can plan in a meeting. Because over there I provide one-on-one Blender lessons. And with that being said, I see you in the next one.